Okay, test. Test 1 2 3 test 1 2 3. Alright, so hello everyone. Jadi hari ini aku mau belajar TypeScript. Aku jujur udah lama banget pakai React dan pakai Vue.js. Udah lama juga pakai jQuery dan sebagainya, tapi aku belum pernah pakai TypeScript gitu. It's because most of my flexibility itu ada di dynamically type-nya. Jadi aku jarang buat kayak in A, in B gitu. Jadi lebih suka pakai let. Tapi udah masuk di era dimana udah jadi standar industri pakai TypeScript terus kan. So yeah, why not? Let's give it a try.
Alright, the first thing we need is Node, because we're going to
Okay.
use Node Package Manager or
Udah
NPM
punya
to install the
notes sih sebenarnya.
TypeScript compiler. I believe as a student of this course, you should have Node on your machine, but if not, head over to nodejs.org and download the latest version over here. Once you do that, then open a terminal window and run npm, that is short for Node Package Manager, which we're going to use for installing third-party packages, in this case, TypeScript. Then we type I, that is short for install, -G for installing this globally, so we can access the TypeScript compiler in every folder. And then we type the name of the package, TypeScript. Now if you're on Mac or Linux and you get a permission error while running this command, you have to prefix it with sudo or sudo. Well, more accurately, this is sudo because it's short for super user do. But that aside, let's go ahead and install the TypeScript compiler.
Okay, is that something? npm -I. Okay, I don't know what the fuck did I just did. Is G an option? Oh, it's I. So it's init, of course. It's initial install or something. Init -G. So you have TypeScript. What is this gonna do? Huh. So oh yeah, it isn't a super user command. Emang bukan sih. Create TypeScript. Yes. Itu artinya apaan? Coba dulu ya. npm -G. What is that? What the fuck? What the hell, man? Huh. No. What? Init is here? The fuck? Jadi penjelasan itu di mana sebenarnya kalau gitu? Hah? Penjelasan buat penggunaan init di mana? Look at that. What is that? Create TypeScript not found. What?
Compiler.
Kita baru mau coba masukin itu.
Okay, great. Now to verify.
Udah masuk. Apa sih namanya? Kita coba install aja udah
Our installation.
What the hell? npm install -G npm exodus, something like that. Okay, let's just try again. Maybe it's I instead of -G then. What does that mean?
We type tsc.
What is I in npm? Install. So we're installing, but there's no. Oh my god! I install here on my. No, it's not. It's not too. Yeah, I'm in this folder. I forgot. What the fuck? Why would I do that? There should be a package JSON here. Please don't tell me I need a sudo. Let's just try and touch something here. Touch. Test. Oh yeah, it is. You don't need sudo, so it's all good. So this should add that here. Or did I just put it on the global?
That is short for TypeScript compiler. -v to get the version. So here I'm running TypeScript version 4.6.3. You might install a newer version, but don't worry, because everything I'm going to teach you here will apply to newer TypeScript compilers. Now, in this course, just like my other courses, I'm going to use Visual Studio Code or VS Code as my code editor. You're welcome to use any editor you prefer, but if you want to follow along and use some of the shortcuts I'm going to teach you, I highly encourage you to use VS Code. In case you don't have it, you can get it. And,
I don't need
okay.
this.
So every time I can drop this folder onto VS Code. Okay. So here's our project. Now let's add a new file here called index.ts. So every TypeScript file should have the TS extension. Now, earlier I told you that TypeScript is built on top of JavaScript. So we say TypeScript is a superset of JavaScript, which means it has everything in JavaScript plus some additional features. So here we can write any JavaScript code, and that is valid TypeScript code. So we can write console.log and print hello world. Now we can go back to our terminal window here, or we can use the embedded terminal window in VS Code. So back in VS Code, under the view menu, look, we have terminal. The shortcut on Mac is Control and backtick. So we can open the terminal window right here, and using TypeScript compiler, we can compile index.ts. Okay, now let's open our project folder. Look, we have index.js, which is the result of compilation. So we have the exact same code here because in index.ts we haven't used any TypeScript features. So let's write a bit of TypeScript code. So here in index.ts, I'm going to declare a variable using the let keyword. I'm going to call it age and annotate it with number. So by typing a colon followed by the type of variable, we can annotate or explain a variable. Now we can initialize it to, let's say, 20. Now here's the beautiful part. Because we have declared age as a number, we cannot set it to a string or another type of object. Look, we get this error right here. It's saying type string is not assignable to type number. This is the beauty of using TypeScript. With TypeScript, we can catch a lot of our mistakes at compile time. We don't have to run our application or our unit tests to find that we accidentally. Accidentally set a number to a string. So let's remove this bad line and recompile our file. So back to the terminal, tsc index.ts. Good. Now take a look over here. Look at the JavaScript code that the TypeScript compiler generated. So instead of the let keyword here, we have var, because by default, the TypeScript compiler uses an older version of JavaScript called ES5, which is short for ECMAScript 5. So ECMAScript is a standard or a specification, while JavaScript is an implementation of that specification. So ES5 is an old specification. It's been around for a long time, and all these features have been implemented in our browsers for a very, very long time. I think more than a decade. Now in the next lesson, I'm going to show you how to configure the TypeScript compiler to target a newer JavaScript version. So the code that will be generated will be more modern. So here's the interesting part. Instead of let, we're using var, and we don't have our type annotation. This is purely for the TypeScript compiler. The actual JavaScript code doesn't specify the type of this variable, okay? So that's it for now. Starting from the next section, we're going to explore TypeScript features in detail. Next, I'm going to show you how to configure the TypeScript compiler. Alright, let's talk about creating a configuration file for the TypeScript compiler. So here in the terminal, we run tsc --init. So this created a configuration file called tsconfig.json with these settings. So let's close the terminal window and open tsconfig right here. So in this file, we have a number of settings and so this created a configuration file called tsconfig.json with these settings. So let's close the terminal window and open tsconfig right here. So in this file, we have a number of settings, and as you can see, most of these are commented out by default. We're only going to use a handful of them. So don't be intimidated by all these settings. You don't have to learn all of them. In fact, nobody knows all of them. I don't know all of them either. Now, in case you're curious, in front of each setting, you can see a description of what that setting is for. So let's talk about a few of them in this lesson. The first one is target, which specifies the version of JavaScript that the TypeScript compiler is going to generate. So this is set to ES 2016, which is an old standard and it's been implemented in all browsers out there. Now, depending on where you want to deploy your application, you can use a higher target, and that often results in shorter and less concise code. So if you remove this value and press Control and space, we can see all valid values. So we have ES 2015, 16, 17, 18, and so on. Now in this lesson, I'm going to leave this at ES 2016 because this is the safest option for all browser applications out there. But again, depending on where you want to deploy your application and how much of older browsers you want to support, you can use a higher target. Now, the next setting we have here is module, which is set to common.js. We'll talk about this setting later in the course where we talk about modules. Now in this section, in the module section, we have a setting called root dir, which specifies the directory that contains our source files. So let's remove the comment by pressing Command and / on Mac or Control and / on Windows. So this is set to /, which represents the current folder. Now, by convention, we often put our source code into a separate folder. So back to our project panel, let's create a new folder here called src, and then move index.ts right here. Okay. Now I'm going to delete index.js. We don't need it for now. Okay. So now we're going to change root dir to /source. Now we have a similar setting here under the emit section. That setting is called outdir, and this specifies the directory that will contain our JavaScript files. So let's enable this and change it to dist. So when we compile our code using the TypeScript compiler, our JavaScript files are going to be stored in dist or distributable folder. Okay. Now here we have another useful setting called remove comments. So if we enable this, the TypeScript compiler is going to remove all the comments that we add in our TypeScript code. So the generated JavaScript code is going to be shorter. Okay. Now another useful setting in this section is no emit on error. So by default, when we compile our code, even if you have errors in our code, the TypeScript compiler will still generate JavaScript files. This is probably not what we want, so the best option is to always enable this setting. So if you have any mistakes in our code, the TypeScript compiler is not going to generate any JavaScript files. Okay? Now, with this configuration file in place, now we can go back to the terminal and compile our code simply by running tsc without any arguments. So we don't have, okay? Our code, we want code on error. So by default, when we compile our code, even if you have errors in our code, the TypeScript compiler will still generate JavaScript files. This is probably not what we want, so the best option is to always enable this setting. So if you have any mistakes in our code, the TypeScript compiler is not going to generate any JavaScript files. Okay? Now, with this configuration file in place, now we can go back to the terminal and compile our code simply by running tsc without any arguments. So we don't have to type index.ts. We just run tsc, and this will compile all TypeScript files in this project. Take a look. All right. Now we have a new folder called dist that contains our JavaScript file. So this was the basics of tsconfig. As we go through the course, we'll explore more of these useful settings. Alright, now let's see how we can debug our TypeScript applications in VS Code. This is very useful when things go wrong and our code doesn't work as expected. So we can run our code line by line and see what exactly happens under the hood. There are a few steps we need to follow. First, we go to tsconfig.json, and here in the emit section, we enable the source map feature. So a source map is a file that specifies how each line of our TypeScript code maps to the generated JavaScript code. Let me show you. So back to the terminal, let's recompile our code. Good. Now look into this folder. We have a new file called index.js.map. This is our source map. So if you look over here, you see some code that specifies how our TypeScript code maps to our JavaScript code. Now, this is not for us to understand. This is for debuggers. It's for machines, okay? So let's close this file. Now, to make debugging more interesting, let's go to index.ts and write some logic. We can say if age is less than 50, you're gonna add 10 to it, okay? Now we're gonna click on the first line to insert a breakpoint. So when we start debugging, the execution stops right at this line, at this breakpoint.
Yeah,
From this point forward, we can execute our code line by line, okay? Now, we go to the debug panel and click on create a launch.json file. Now from this dropdown, we select node.js, and this creates a new file called launch.json. We select node launch. We go to the debug panel and click on create a launch.json file. Now from this dropdown, we select node.js, and this creates a new file called launch.json in our project. I'll show you that in a second. So this is a JSON file with some configuration that tells VS Code how to debug this application. So we're going to use node to launch this program, and here we have a label called launch program, which you will see in a second. And we can see our program starts here. So in the source folder, we have index.ts, and our output files are stored in our workspace in our project in files with the JS extension. Now here we need to add one more setting. It's called pre-launch task. We're going to set this to a string with this value, tsc space build space hyphen space tsconfig.json. Make sure to type this out exactly as I've shown you here. All these spaces matter, okay? So with this setting, we're telling VS Code to use the TypeScript compiler to build our application using this configuration file, okay? Now, we go back to index.ts, and to start debugging, we can go to the debug panel and click on launch program. This is the label that I just showed you. Now look at the shortcut, it's F5. I always prefer to use shortcuts. So let's start debugging. Good. Now our program started and the execution stopped right on this line at this breakpoint. Now on the top, we have a bunch of tools for executing our code. We have step over for executing one line. We have step into for stepping into a function. Currently, we don't have any function, so it's not useful. We also have step out. This is useful for stepping outside of a function. We have restart and stop. So in the tooltip that you see in front of each tool, you can see the shortcut. So the shortcut for stepping over a line is F10. Let's press that. So this line was executed. Now on the left side, under variables, you can see all the variables that are detected in this debugging session. So under local, we have age that is set to 20. As we execute each line, you will see the value of this variable getting updated.
Oh, I need
now,
to
if there's something fine, is
okay.
TS is a JSON index.ts, and to everything VS Code, okay, go to the debug panel. Now node, node. I'll show you that in a second. Forward, we're going to stand 50. We're going to add 10 to it, okay? Now we're going to click on the first line to insert a breakpoint.
Oh,
so when we start forward, go to JSON, and this creates a new, here we have a pre-launch task. We're going to set to type this out exactly as I've shown you here. All these spaces matter, okay? So with this setting, we're telling VS Code to use the TypeScript compiler to build our application using this configuration file, okay? Now, we go back to index.ts, and to start debugging, we can go to the debug panel and click on launch program. This is the label that I just showed you. Now look at the shortcut, it's F5. I always prefer to use shortcuts. So let's start debugging. Good. Now our program started and the execution stopped right on this line at this breakpoint. Now on the top, we have a bunch of tools for executing our code. We have step over for executing one line. We have step into for stepping into a function. Currently, we don't have any function, so it's not useful. We also have step out. This is useful for stepping outside of a function. We have restart and stop. So in the tooltip that you see in front of each tool, you can see the shortcut. So the shortcut for stepping over a line is F10. Let's press that. So this line was executed. Now on the left side, under variables, you can see all the variables that are detected in this debugging session. So under local, we have age that is set to 20. As we execute each line, you'll see the value of this variable getting updated. Now, if there's something that you don't see in the variables window, you can go to the watch window and insert a watch. So we're gonna watch the age variable. Currently it's 20. So let's step over this line. Now we're on this line. So let's step over this as well. Now age got updated, but because our program terminated, we don't see its value anymore. But if you add one extra line here, let's say console.log age. Let's start the debugging session one more time by pressing F5. Now step over F10, 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 and now age is 30. So this is debugging in VS Code. It's very useful when things go wrong. We can start our program and execute it line by line. All right, now that we're done with debugging, we can stop the debugging session in VS Code. It's very useful when things go wrong. We can start our program and execute it line by line. All right, now that we're done with debugging, we can stop the debugging session.
It doesn't
right
add
here.
the fucking age. Oh, it does.
So that brings us to the end of this section. Starting from the next section, we're going to explore TypeScript in detail.
Okay, cool. That's a nice
Hey guys,
start.
Mosh here. I just
never
wanted to
knew
let you
about
know
the
that this
debugging
tutorial you
button
have been
before.
watching is
Oh my
actually
God.
the first hour of my complete TypeScript course. The complete course is about 5 hours long and goes way beyond this tutorial. It also comes with exercises and solutions, summary notes and cheat sheets, a 30-day money-back guarantee, and a certificate of completion you can add to your resume. So if you're serious about learning TypeScript and the fundamentals of TypeScript. So you will learn about the built-in types like the anytype, arrays, tuples, enums, functions, and objects. The concepts you will learn in this section will be the foundation for future sections, so don't skip any lessons. Now, let's jump in and get started. So JavaScript has built-in types like number, string, boolean, null, undefined, and object. Now TypeScript extends this list and introduces new types like any, unknown, never, enum, and tuple. As we go through this section, you will learn about all these types in detail. But before we get started, let's see how we can play with primitive types in TypeScript. So back in index.ts, I'm going to delete all this code and declare a variable called sales of type number and set it to a value like 1, 2, 3, 4, 5, 6, 7, 8, 9. So once again, we're annotating or explaining the type of the sales variable using this syntax, okay? Now in TypeScript, if you have a large number, we can separate its digits using an underscore.
Holy shit,
That
really?
makes our code more readable, okay? Now let's also declare a variable called course of type string and set it to TypeScript. And one boolean called is published. Now let me show you something really cool. In TypeScript, we don't always have to annotate our variables because the TypeScript compiler can infer or detect the type of our variables based on their value. For example, because we have initialized this variable to a number, the TypeScript compiler knows that this variable is a number, so we don't have to annotate it. So if we remove the annotation and hover our mouse over this variable, look, we can see that sales is a number. Similarly, because we have initialized course to a string, we can remove the annotation, and once again, we can see that course is a string. And one more time. Now, what if we declare a variable like level and don't initialize it? TypeScript assumes that this variable is of type any. We'll talk about that in the next lesson. In TypeScript, we have a new type called any, which can represent any kind of values. So if we declare a variable and don't initialize it, the TypeScript compiler assumes this variable is of type any. So we can set it to a number, and then later on we can set it to a string. But this is against the whole idea of using TypeScript, because we use TypeScript for type safety, so we get type checking. So if we use the any type, we essentially lose that feature and the major benefit of using TypeScript. So as a best practice, you should avoid using the any type as much as possible. Let's look at another example. Let's say we have a function called render that takes a document and simply renders it on the console. Now look, we have a compilation error, and the error is saying parameter document implicitly has an any type. Implicitly means we haven't explicitly or clearly set the type of this parameter. So the compiler is inferring or guessing the type of this parameter. And that's why we have this error. Now, let's say this is part of a JavaScript project we're trying to convert to TypeScript, and at this point, it's impossible for us to explicitly annotate this with a particular type. So we have to use the any type here. Now here we have two options. To turn off this error, one option is to annotate this with any. So we're telling the compiler, hey, I know what I'm doing, the document is of any type. But what if we have tons of errors of this kind? We don't want to go to every function and explicitly annotate various parameters with any. Well, there is a nuclear option for that, but I don't personally recommend that. But let me show you how that works. So let's remove the annotation. Now if you bring on the comment, the error is gone. So
oh my God,
use
no,
this with major an array like this. Now, the thing about JavaScript arrays is that each element can be of different type. So here we can have two numbers followed by a string. And this is totally valid JavaScript code because JavaScript arrays are dynamic, so each element can be of different type. But what if we pass this array to a function that expects a list of numbers? Then the third element is going to cause some issue, right? This is where we use TypeScript. So we can explicitly apply a type annotation here and say numbers is a number array. Now we see the error immediately at compile time. So let's fix it. Good. Now in this particular case, we don't even have to apply the type annotation because every element in this list is a number. So if you remove the type annotation, the compiler can still infer or guess the type of this variable. Great. But what if we had an empty array here? Look, now the type of this variable is any array, which is something we should avoid. With any arrays, again, we can have a mix of different types. So the first element can be a number, the second element can be of a different type, like a string or a boolean. So if you want to use an empty array, you have to explicitly apply a type annotation here. Let's say number array. Now the third line is invalid, so let's delete it. Now let me show you another cool benefit of using TypeScript, and that is code completion or IntelliSense. So if we type numbers for each and pass an arrow function here like n goes to, and then type n period, over here we can see all the properties and methods of number objects. Because our editor knows the type of n, it offers code completion, so we can see all the methods of number objects. This is very useful. It's a great productivity boosting feature. We don't get this with plain JavaScript, right? So that's another benefit of using TypeScript. That's all about the arrays. Next, we're going to talk about tuples. TypeScript has a new type called tuple, which is a fixed length array where each element has a particular type. We often use them when working with a pair of values. For example, let's say for each user, we want to represent two values, an ID and a name. So we declare a variable and annotate it using a special syntax like this. First, we add square brackets and then tell the compiler that the first element is going to be a number, whereas the second element is going to be a string. And then we initialize our variable like this. So we have a fixed length array with exactly two elements, nothing more, nothing less. So if we add a third element here, we get a compilation error saying type number string number is not assignable to type number string. Okay? So exactly two elements, and these elements should have these types. The first one has to be a number. So if we pass a string, again, we get a compilation error. Now, just like before, here we get IntelliSense or code completion. So if we access the first element, we see all the methods of number objects. And if we access the second element, we see all the properties and methods of string objects. Again, one of the reasons I love TypeScript. Now, one thing you need to know about tuples is that internally they're represented using plain JavaScript arrays. So if we compile our code, we're just going to see a regular JavaScript array. Let me show you. So here in the terminal, let's run tsc. Good. Now, back in our project, here in this folder, let's open index.js. Look, we just have a regular JavaScript array. So that means, back in our TypeScript code, if we type user period, over here we can see all the methods of array objects. Now one of these methods is a little bit troublesome, and that is the push method. So we can call this method and store a third value in this array, and the compiler is not going to complain here. I believe this is one of the gaps in TypeScript at the time of recording this. Hopefully this will be solved in the future. So a tuple is a fixed length array where each element has a particular type. Now, as a best practice, I would say restrict your tuples to only 2 values, because anything more than that is going to make your code a bit hard to understand. For example, if we add a boolean and another number here, what do these values really represent? It's really hard to tell. So tuples are useful when we have only 2 values, like key value pairs. Next, we're going to talk about enums. TypeScript has another built-in type called enum, which represents a list of related constants. If you know C# or Java, you have seen enums before. We have the exact same concept here in TypeScript. So let's say we want to represent the size of t-shirts as constants. One way is to define 3 constants like this: small, medium, and large. That's one way, and then throughout our code, we can reference these constants. Another way is to group these constants inside an enum. So we use the enum keyword, then give our enum a name. Now note that here I'm using Pascal naming convention, so the first letter of every word should be uppercase, okay? Then we add curly braces, and inside the braces we add our members: small, medium, and large. Once again, I'm using the Pascal naming convention for the members. Now when we define an enum, we don't need to define these 3 constants anymore. And by default, the TypeScript compiler assigns the first member the value of 0, and other members values like 1, 2, and so on. Now if you don't want to use these values, we can explicitly set values. So we can set small to 1, and then medium becomes 2, and large becomes 3. We can also use string values like s. If we do this, then we have to explicitly set a value for each member. So medium and large, like this. Now I'm going to revert this code and just rely on numbers. So I'm going to initialize small to 1 and rely on the compiler to set the value for other members. So now that we have this new type, we can declare a variable like mySize of type size and set it to size dot medium. Okay? So this is how we can use enums. Now let's see what happens if we log mySize on the console. So back to the terminal, let's run the TypeScript compiler. Good. And then use node to execute our JavaScript code. So we go to the dist folder and pick index.js. So look, we see the numeric value associated with our enum member. Okay. Now let's look at the generated JavaScript code in this file. So back to the project, here's our index file, take a look. So the generated JavaScript code is pretty verbose, it's pretty lengthy. Now you don't need to worry about understanding this, but let me show you a trick. Back to our TypeScript file, if we define this enum as constant, the compiler will generate a more optimized code. So let's recompile our code, and then look at index.js one more time. Now we don't see all that code anymore. We only have one line for setting mySize to 2. Again, you don't have to worry about the generated JavaScript code. All I want you to take away here is that using an enum, we can represent a list of related constants. And if we define our enums using the constant keyword, the compiler will generate more optimized code. Next, we're going to talk about functions. Let's talk about how TypeScript helps us prevent common problems when working with functions. So let's define a function called calculateTax and give it an income parameter of type number. Now, let's hover our mouse over the function name. Look at the type of the return value. It's void, meaning this function does not return a value. If we return a value here, like a number, now the type of the return value is number. So the TypeScript compiler has inferred the the type of the return value for us, and that's great. But as a best practice, we should always properly annotate our functions. So all the parameters as well as the return type should be properly annotated, especially if you're building an API for other people to use. So in this case, to annotate the return type, we go after the list of parameters, add a colon, and specify the return type, like number, or void if you're not going to return a value. So let's add number. Now this has an extra benefit. If you forget to return a value, or if you return a different kind of value like your string, you get a compilation error immediately. So as a best practice, always properly annotate your functions. Now let's temporarily return 0. Okay? Look at the income parameter. This is an unused parameter. Now we have a compiler option for detecting these unused parameters. So let's go back to our tsconfig file. In the type checking section, we have a compiler option called no unused parameters. We have to explicitly turn this on because this setting is not part of strict setting. Now back to index.ts. Look, we have a warning saying income is declared, but its value is never read. So let's change this code and say if income is less than 50,000, then we're going to return income times 1.2. Now here we have another configuration error saying function max ending return statement and return type does not include number. It sounds a bit cryptic, and this really is saying is that if this condition is true, we're going to return a number. Otherwise, as you know, JavaScript by default always returns undefined functions, and undefined is not a number. Now, let me temporarily remove the annotation for the return type. There's then other option called no unused parameters. You have to explicitly turn this on because this setting is not part of strict setting. Now back to index.ts. Look, we have a warning saying income is declared, but this value is never read. So let's change this code and say if income is less than 50,000, then we're going to return income times 1.2. Here we have another configuration error saying function lacks ending return statement and return type does not include number. It sounds a bit cryptic. What this error is saying is that if this condition is true, we're going to return a number. Otherwise, as you know, JavaScript by default always returns undefined functions. And
so
undefined
is
not a number. Now, let me temporarily remove the annotation for the return type. Look, we have no compilation error, but this function has a problem. If the income is greater than 50,000, we're going to get undefined from this function, and this may cause a bug in our application. The good news is that we have another compiler option for detecting these kind of issues, where we forget to return a value. So back to our tsconfig file. Again, in the type checking section, we have a setting called no implicit returns. Again, we have to explicitly turn this on because this is not part of the strict setting. Okay? Now, after code, we have a warning saying not all code paths return a value. So now we can fix this problem and say otherwise, if income is greater than 50,000, we're going to return income times 1.2. But again, it's best to always annotate our function properly to prevent all these issues. So we should always return a number on this function. Now we have another useful compiler setting for detecting unused variables. So if you declare a variable like x and don't use it in this function, this is unused. Now using the TypeScript compiler, you can find these issues in your code. So back to tsconfig, here is the setting, no unused locals. With this feature enabled, now make these issues in your code. So back to tsconfig, here is the setting, no unused locals. With this feature enabled, now after a code, we have a yellow warning saying x is declared, but its value is never read. So now we can delete this and make our code clean. So this is the basics of functions. Now let's add a second parameter called tax year of type number. Now we have a warning here saying tax year is declared, but its value is never read. So let's change our condition to if tax year is is less than 2022, then return income times 1.2. So now with these two parameters, if you want to call this function, you have to supply exactly two arguments, nothing more, nothing less. So I'm going to pass 10,000 for income and 2022 for the tax year. If you add an extra argument here, you get a compilation error saying expect the two arguments for both three. If you have been coding in JavaScript for a while, you know that this is valid JavaScript. So JavaScript doesn't really care how many arguments we pass to the function. You can pass more or fewer arguments than the number of parameters. But TypeScript is very strict about this. So here we should pass exactly two arguments. So let me show you that. But what if we want to make this optional? Let's say in some cases we want to call this function without supplying tax year. We can make this parameter optional by adding a question mark right here. Now, we have a compilation error on this line saying object is possibly undefined. It's straight up. We have a little warning saying x is declared, but its value is never read. So now we can delete this and make our code clear. So this is the basics of functions. Now let's have a second parameter here called tax year of type.
Tapi tanda-tanya buat apa?
Now we have a warning here saying tax year is declared, but its value is never read. So let's change our condition to if tax year is less than 2022, then return income times 1.2. So now with these two parameters, if you want to call this function, you have to supply exactly two arguments, nothing more, nothing less. So I'm going to pass 10,000 for income and 2022 for the tax year. If you add an extra argument here, you get a compilation error saying expect the two arguments for both three. If you have been coding in JavaScript for a while, you know that this is valid JavaScript code. So JavaScript doesn't really care how many arguments we pass to a function. We can pass more or fewer arguments than the number of parameters. But TypeScript is very strict about this. So here we should pass exactly two arguments. So let's remove that. But what if you want to make this optional? Let's say in some places we want to call this function without supplying the tax year.
Optional.
We can make this parameter optional by adding a question mark right here. Now, we have a compilation error on this line saying object is possibly undefined. So if we don't supply the tax year, by default, undefined will be used, and we cannot compare undefined with 2022. So here we have two options. One option is to use the old JavaScript trick. So we wrap this in parentheses, and then using the OR operator, we give it a default value, like 2022. So if you don't supply the tax year, this value will be used. Otherwise, the argument that we pass will be used here. Okay? Now, I don't like this approach. There is a better one. We can give this a default value. So instead of making it optional, we give it a default value, like this. Now we can call this function with or without a tax year. If we don't supply an argument for the tax year, this value will be used. Otherwise, what we pass here will overwrite the default value, okay? Now, with this default value, we no longer need to use this ugly expression. We can simply compare tax year with 2022. So let's quickly recap what you learned in this lesson. As a best practice, always properly annotate your functions, all the parameters and return types, and enable these three compiler options. No unused locals, no unused parameters, and no implicit returns. Alright, the last thing we're going to cover in this section is objects. So let's declare an employee object with an ID.
Ya, aku lebih terbiasa pakai yang ini sih.
ID property. Now, you know that in JavaScript, objects are dynamic, so their shape can change throughout the lifetime of our programs. So once we have an employee object, then later we can give it a new property like name, and this is totally valid in JavaScript. But as you can see, this is not valid in TypeScript. The compiler is saying property name does not exist on this type. So this type is an object with an ID property, which is a number. So just like all the variables we have declared so far, the TypeScript compiler has inferred the shape of this employee object. So if you hover our mouse over employee, we can see its shape. It's an object with an ID that is a number. Now, just like all the variables we have declared so far, we can explicitly apply a type annotation here. So after employee, we add a colon followed by braces, and inside the braces we define the properties of an employee object. So every employee should have an ID that is a number and a name that is a string. Now the previous error on this line is gone, but we have a new kind of error. Let's find out. The compiler is saying property name is missing. So the reason we're seeing this is because every employee should have these two properties, but while initializing this object, we haven't supplied the name property. Now here we have two options. One option is to set the name to an empty string. We cannot set it to null or undefined. We'll talk about this in the next section. So we should either set it to an empty string, or we can make this property optional, and then we don't have to supply the name property while initializing an employee. Now, even though TypeScript allows us to do something like this is something we should avoid, because conceptually it doesn't make sense to have an employee without a name. Every employee should have a name. It would make sense to make the fax property optional, because not everyone has a fax machine, right? So always make sure the code you write conceptually makes sense. Don't blindly use features of TypeScript or any other programming languages, okay? So in this case, we're not going to use an optional property, and that means we should either set the name to an empty string or initialize it right here, okay? Now we have an error because I used a period. Okay, so now we don't need this last line anymore. Okay, now sometimes we want to make certain properties read-only so we don't accidentally change them later on. So with our current implementation, we can change the ID of an employee anytime, and this is not valid. This is where we use the read-only modifier. So we apply it before the name of the property, and now the TypeScript compiler prevents us from accidentally modifying the value of this property. Okay, only modifier. So we apply it before the name of the property, and now the TypeScript compiler prevents us from accidentally modifying the value of this property. Okay, good. Now, how can we define a function, or more accurately a method in this object? Let's say every employee object should have a retire method. So in our type annotation, we need to define the signature of this method. We need to specify how many parameters it's going to have, what is the type of each parameter, and what is the type of the return value. So we're going to have a retire method with one parameter, that is date. Now here we use the arrow function syntax. So first we add parentheses, and inside parentheses we specify the parameters. So we're going to have a date parameter of type date. This is just a built-in date object in JavaScript and TypeScript. So we only have one parameter, then we use a fat arrow, and here we specify the type of the return value. We don't want to return any value, so we're going to use wait. Now, you have a compilation error saying property retire is missing, because when initializing this object, we haven't supplied the retire method. So let's do that real quick. Alright, retire is going to be a method with one parameter, and over here, I just want to log the date on the console. Pretty simple. So this is how we can work with objects. Now I know this syntax, this type annotation is a little bit messy. It's making our code a bit verbose or noisy. So in the next section, I'll show you a better way to work with objects. Welcome back to another section of the Ultimate TypeScript course. In this section, we're going to explore more advanced types in TypeScript. So you will learn how to use type aliases to reuse types and simplify your code, how to use unions and intersections to compose. Welcome back. Better way to work with objects. Welcome back to another section of the Ultimate TypeScript course. In this section, we're going to explore more advanced types in TypeScript. So you will learn how to use type aliases to reuse types and simplify your code, how to use unions and intersections to combine types, how to narrow types, how to work with nullables, as well as the unknown and never types. So let's jump in and get started. Alright, so this is the employee object that we created at the end of the previous section. Now, there are 3 problems in this implementation.
Can I just install some TypeScript? I don't know. Prettifier. What is this? What the hell is this? Uninstall. What the? Should be configure. Use this one. Okay.
The first problem is that if we want to create another employee object, we have to repeat this structure. We have to repeat this shape. So we'll end up duplicating our code, which is bad. We always want to confirm to the dry principle. Don't repeat yourself. Now, the second problem is that the other employee object might have other properties. So these 2 employee objects might not have a consistent shape because we don't have a single place to define the shape of an employee object. Now, the third problem is that overall, this structure is making our code a little bit hard to read and understand. This is where we use a type alias. Using a type alias, we can define a custom type. Let me show you. So on the top, we start with the type keyword, then give our new type a name, and once again here we use the Pascal case. So employee with a capital E. Then we set it to braces, and inside the braces we define all the properties and methods an employee object should have. So I'm going to go in this annotation, select these 3 lines, and by pressing Alt and up, we can move these lines up. Okay? Now when defining this employee object, we annotate it with our new type, employee. Okay?
Ooh.
So now we have a single place where we define the shape of an employee object, and we can reuse this in multiple places. This is the benefit of using a type alias.
This is really cool.
Alright, let's talk about union types. With union types, we can give a variable or a function parameter more than one type. So let's define a function for converting weight from kilogram to pounds. Now we give it a parameter called weight. Now let's assume that this parameter can be either a number or a string. So we annotate it with number or string. So using a vertical bar, we can create a union type. Now we can call this function in 2 ways. We can give it a number or a string like 10 kilograms. Okay? Now let's finish up this example. So we're going to annotate the return type and return a number. Now in this function, at this point, we don't know if the weight is a number or a string. So if you type weight period, we only see the properties and methods that are common between numbers and strings. So both numbers and strings have these 3 methods: to locale string, to string, and value of. So here we are not seeing methods that are specific to numbers or strings. And this is where we use a technique called narrowing. So we're going to narrow down this union type into a more specific type. So here we can say if type of weight equals number. Now in this block, the compiler knows that the weight is a number. So if we type weight period, we see all the methods that are available in number objects. And by the way, we don't necessarily need the code blocks here. In this line, if you have a one-liner and type weight period, we still see all the methods available in numbers. Okay? So what are we going to do here? We're going to return weight times 2.2. Otherwise, if we end up here, that means weight is a string. So now we see all the properties and methods of string objects. Okay? So to finish this example, here we're going to return. First, we need to convert the weight to an integer. So we call parseInt, pass the weight, and then multiply it by 2.2. Okay? Now back to the terminal, let's compile our code and see what we get. Alright, we're going to go to index.js. Take a look. Our union type is not part of the generated JavaScript code. It's purely for the compiler to do its type checking. It's purely for the compiler to do its type checking. So in the previous lesson, you learned that using a union type, we can say a variable or a function parameter can be one of many types, right? Now we have another technique for combining types called intersection. So instead of a vertical bar, use an ampersand. And now this type represents an object that is both a number and a string at the same time. Now technically, this is impossible. We cannot have an object that is both a number and a string at the same time. So let's look at a more realistic example. I'm going to use our type alias to define a new custom type called draggable. So this represents an object that can be dragged on the screen. Now what properties or methods do we need in a draggable object? Well, at least we need a method called drag, which takes no arguments and returns void. Now similarly, we're going to define another type called resizable. And here we need a resize method that should take two parameters like the new width and the new height. But for simplicity, let's get rid of all that noise and just add no parameters and say this method returns void. Okay? So now we have two separate types, and using an intersection type, we can combine them into a new type. So we can define a new type called UI widget, which is draggable and resizable. So this is an intersection type. Now with this type in place, we can declare a variable called textbox, which is a UI widget. Now to initialize this object, we need to implement all members of draggable and resizable objects. So we need to implement the drag and resize methods. So drag is a simple method, and so is the resize method. So this is type intersection in action. Sometimes we want to limit the values we can assign to a variable. This is where we use literal types. So let's declare a variable called quantity and assume that the quantity can either be 50 or 100, but nothing else. Now here's the problem. If we annotate this with number, this can take any numbers, any valid numbers in JavaScript, right? So to limit the values we can use here, we use a literal type. So instead of annotating this with a type like number, we'll annotate it with a literal, meaning an exact or specific value. So I'm going to replace number with 50. Now quantity can only be set to 50, nothing else. So if you set it to 51, you get a compilation error. Now you might think this is not useful. Well, that's true. But what if we apply the union operator here? So we can say the quantity can be 50 or 100. Now we can set it to 50 or 100, right? But we're not done yet. We can make this code even better. So instead of hard coding these literal values here, we can create a custom type using a type alias. So we define a new type called quantity, which can be 50 or 100. And then we annotate our variable with our new type. So what we have over here is called a literal type. Now literals don't have to be numbers, they can also be strings. For example, we can define a new type called metric, which can be centimeter or inch. Okay? So that's all about literal types. Next, we're going to talk about nullable types. Alright, let's talk about working with null values. So by default, TypeScript is very strict about using null and undefined values because, as you probably know, these values are a common source of bugs in our applications. So let's look at a real example. Let's define a function called greet that takes a name, which is a string. Now in this function, we just want to do a console.log and print name.toUppercase. Now in vanilla JavaScript, we can call this function and accidentally give it null or undefined. That is totally valid JavaScript code. But when we run our program is going to crash because we cannot call this method on a null or an undefined object. So this is why null and undefined values are a common source of problems. And that's why, by default, the TypeScript compiler stops us from using null or undefined values. So here we have an error saying argument of type null is not assignable to parameter of type string. Let me show you where this comes from. So let's go to our tsconfig file. In the type checking section, we have a compiler option called strict null checks. Now this is enabled by default as part of the strict option. So if strict is set to true, strict null checks is also true. But we can overwrite it and turn off this feature. Now, back to index.ts, the error is gone. So this is why, by default, TypeScript is very strict about using null values. So technically we should never use this option, we should never turn it off. So I'm going to revert this back. But what can we do in this function? What if we want to have the ability to use a null value? Perhaps if we don't have a name, we want to print just a generic message like hola, meaning hi in Spanish. So here we can say if name is truthy, meaning it has a value, then we're going to print name.to uppercase. Otherwise, if it's null or undefined, we're going to print hola. Okay? But we cannot pass a null value here. This is where we use a union type once again. So we annotate this parameter with string or null. Now we can pass a null value, but we cannot pass undefined because this is not a valid value for this parameter. So if you want to have the ability to pass undefined as well, again, we're going to use the union operator. Now, when working with nullable objects, we often have to do null checks. For example, let's define a type alias called customer and give it a birthday property of type date. Now let's define a function for getting a customer from a database. So we give it an ID, which is a number, and we get either a customer or null in case there is no customer with the given ID. Now in this function, let's write some basic logic like return if ID equals 0, then we return null, otherwise we return a customer object with this birthday. Pretty simple. Now let's declare a variable, and here we call getCustomer and pass 0. Now let's imagine we want to print the customer's birthday. So console.log, and here we pass customer.birthday. Now here we have a compilation error because customer might possibly be null. So as you know, one way to solve this problem is like this. We check if customer is not null, then we execute this piece of code. Now let's take this to the next level and assume that under certain circumstances, this function might return undefined. So we add undefined here. And now we have to expand this if statement and check for undefined. So if customer is not null and it's not undefined either, then we print might possibly be null. So as you know, one way to solve this problem is like this. We check if customer is not null, then we execute this piece of code. Now let's take this to the next level and assume that under certain circumstances, this function might return undefined. So we add undefined here. And now we have to expand this if statement and check for undefined. So if customer is not null and it's not undefined either, then we print the customer's birthday. That works, but there is a simpler way to write this code in TypeScript. We can remove this if statement and use what we call the optional property access operator. So because customer might be null or undefined, right after it we add a question mark and then we add the chaining or the dot operator. So this question mark followed by the chaining operator is called the optional property access operator. So now this piece of code gets executed only if we have a customer that is not null or undefined. Let's see this in action. So we're passing 0 and we get a null object. So if we execute this code, we get undefined. So the result of this expression is undefined. But if we pass 1, we get an actual customer object. So we'll see the customer's birthday on the console. There you go. Okay, so this is optional property access operator. Now we can take this to the next level. Let's make the birthday property optional. Now let's say we want to print the full year of the birth year. So over here, we have to call dot get full year. Now, once again, we have the same compilation error because the birthday property might possibly be undefined. Once again, to solve this problem, we can use the optional property access operator. So now this piece of code gets executed only if we have a customer and that customer has a birthday. Otherwise, the result of this expression is undefined, okay? Now we also have what we call optional element access operator. And this is useful when you're dealing with arrays. So we might have an array of customers and we want to print the first customer on the console. Now, if this array is going to be null or undefined, of course, we have to check if customers is not null and it's not undefined, then we're going to access the first element. Now, this is where we can use the optional element access operator. So before accessing this element, we use a question mark and a dot. Okay. Now we also have the optional call operator, which has the exact same syntax. So let's imagine we have a variable called log, which is going to reference a function. So for simplicity, I'm going to annotate this with any, and this might be set to a function, like a function that takes a message and prints that message on the console, or we might set this to null, right? Now, let's say we want to call this and pass some value. If we run this program, our program is going to crash because log is null. So this is where we can use the optional call operator. So this piece of code will get executed only if log is referencing an actual function. Otherwise, will get undefined. Hey guys, Mosh here. I just wanted to let you know that this tutorial you have been watching is actually the first hour of my complete TypeScript course. The complete course is about 5 hours long and goes way beyond this tutorial. It also comes with exercises and solutions, summary notes and cheat sheets, a 30-day money-back guarantee, and a certificate of completion you can add to your resume. So, if
Pretty well done. Very well done. Lumayan juga ya. Ini itu optional chaining. Intinya dia cuma ngecek kalau itu nilainya ada atau enggak. No atau undefined. So that's really nice. Now how do I get to exercise something here? Break dulu nggak sih? Kayaknya aku mau break dulu. Yep. Oke deh. Thank you everyone. Udah temenin belajar TypeScript. It's pretty simple. I liked it. Ya ada beberapa pain points sih yang aku dapetin dan dari JavaScript itu udah ke-solve di sini. Especially yang masalah itu, masalah penggunaan type dan juga masalah penggunaan apa sih yang constant enumeration itu yang dimana kita harus sebutin satu-satu. Yeah, I feel that as well. Mungkin next step aku coba implement ke project-project aku di Next.js atau mungkin di React. But yeah, we'll see later. Alright then, bye everyone.